Lesson 1.5 is actually our last section in Chapter 1 before our test. However, 1.5 is kind of daunting, so we're going to break it up into two parts. And the first part is we're just going to concentrate on simplifying trigonometric expressions. Tomorrow, we're going to talk about proving trigonometric identities. So first, we need to think about exact expressions. So the question says, if the cotangent of theta is 4, what is the tangent? Well, remember, cotangent and tangent are reciprocals, so the tangent would be a reciprocal of 4, which is a 1 over 4. And then here, for this one, I'm going to draw myself a little picture. And it says we're between 0 and 90, so we're in the first quadrant. It says the cosine is square root of 3 over 2. Well, remember, cosine was x over r. So I'm going to draw myself a little picture. Whoop, that's supposed to be a right triangle. Try again. Good enough. And the x is the square root of 3, and the r value is a 2. So to find cosecant, which is, as we know, let's see, is a reciprocal sine, so it'd be r over y, I need to know how big the y component is. We're going to have to do a little Pythagorean theorem. So the hypotenuse squared is square root of 3 squared plus y squared. So 4 equals 3 plus y squared. Subtract 3 and square root, and we end up with the y value is equal to 1. So now that we know the y value is a 1, we can go back and say r over y would be 2 over 1, which is a 2. Okay. The next problem, again, I'm going to draw myself a little picture because sine and cosine are not directly related. So draw yourself a right triangle in the first quadrant. Sine is 3 over 5. And then for cosine, I need to know the x component. So we're going to have to do a little bit of, well, actually, no, we don't have to do Pythagorean theorem. That's a special right triangle. So I know the x value is going to be a 4. So cosine, of course, would be x over r, which is 4 over 5. And then tangent and cosine are not directly related. So again, I'm going to draw myself a picture. So tangent would be 4 over 3, like this. For cosine, we need to know the r value, and again, this is a 3, 4, 5 triangle, so I don't have to think too hard. Cosine, therefore, would be x over r, which is 3 over 5. Okay, so this time, we're no longer in the first quadrant, we're between 90 and 180, so we're going to be in quadrant number 2. So they tell you that the cosine, oh, I don't have to draw a picture for this one, is negative 7 over 8, so the secant would be his reciprocal, which is negative 8 over 7. So we don't need a picture because that was directly related. Cosecant and cotangent, however, are not directly related. So again, we're in the second quadrant. Cosecant would be r over y, and this is a special right triangle. This is a Pythagorean triple. It's a 5, 12, 13, so I'm going to go ahead and label this as a negative 12 because it's going left, and they want to know cotangent. So cotangent would be adjacent over opposite because it's a reciprocal tangent, so he is negative 12 fifths. Alright, and then this last section here, we're going to be in the third quadrant, fourth quadrant, 270 and 360 is between here and here. And again, we're going to draw ourselves some pictures because sine and cosine are not directly related. So if the cosine is 6 over 7, that means he's 6 and he's 7. Do a little Pythagorean theorem to figure out your r value. Or no, we know our r value, we got to find our y value. So 7 squared equals 6 squared plus y squared. So let's see. Looks like it's, oh jeez, going to be a square root of 13. So this is the square root of 13, and because he's down, he's actually the negative square root of 13. So the sine is the y over the r, so the sine is negative square root of 13 over 7. Number 8, cosecant and sine are not, oh, they are directly related. They're inverses, or reciprocals of one another. So the sine is going to be a negative 4/9. So when they are directly related because they're reciprocals, very easy question. Now on the back, we're actually going to get into simplifying these trigonometric expressions, and we're going to do some what we call trig trades. So the top here is a bunch of identities that we need to think about. So if I ever saw tangent, I could flip them into sine over cosine instead of a tangent, which usually is the way we want to go. Sometimes you want to take tangent and put him as his reciprocal cotangent, but not always. So first, cosecant. Instead of putting him as, well, the only thing we can put cosecant as is his reciprocal, which is 1 over sine. And then tangent, I'm going to refer back to this part. Tangent is sine over cosine. And then once you do your trig trades, your job is to cancel and see what it reduces to. So the sines would end up canceling, and you have a 1 over cosine, but your trig teacher's not going to like that answer. So we have to think 1 over cosine is really the function secant, and that's the answer we're going to be looking for. So you have to go until you get the cleanest, most simple answer you can get. Now, sine squared over tangent squared. We have to think about whether we want to use what's called a Pythagorean identity or just the normal sine, cosine, and tangent reciprocal identities. And I don't really want to introduce the Pythagorean identity quite yet. I'm going to try going a simpler way. So sine squared, and they put the squared before the theta for some reason in trig, over tangent squared. Tangent squared I can change. So if tangent is sine over cosine, that means tangent squared is sine squared over cosine squared. And depending on how good you are with fractions, you might be able to see right now what cancels. It turns out that these signs are going to cancel each other out, but if you can't see that in a vertical notation, you can change this to be a horizontal multiplication problem. Remember, dividing by a fraction, same thing as multiplying by his reciprocal. And now you can easily see that the sine squareds cancel, leaving you with just cosine squared. Theta. Okay, same idea here, sine squared theta, I'm going to keep. But cotangent, I'm going to flip. Cotangent cosine over sine, so cotangent squared is cosine squared over sine squared. So now I see that sine squareds cancel. If you do this and nothing ends up canceling, you probably made a mistake. And we are left with cosine squared. Now number 12, you might not know what to do with it at first, but when I'm looking at number 12, I'm seeing actually a foiling problem. So we're going to start by taking the first and multiplying them just like you would with any other foiling problem. And then the outer, then the inner, and then the last. So cosecant times cosecant is cosecant squared theta. I notice here that it's going to be a negative cosecant plus a positive cosecant, and they're going to cancel, so I'm not going to write that down. And then 1 times negative 1 is a minus 1. Now this is a little strange because we haven't talked about it yet, but there's something called a Pythagorean identity. There's 3 of them. And if I look at this one right here, he's got a cosecant squared, he's got a 1. If I kind of rearrange it by maybe subtracting this 1 over, I'm going to see that cotangent squared theta is the same thing as cosecant squared minus 1. So cosecant squared minus 1 is really cotangent squared. You're going to get really good at manipulating those in your head. Oh my, 13. Okay, there's a lot going on in 13. First thing I notice is that this numerator is really this guy rearranged, like we just saw. But this time, instead of subtracting the 1, what if we subtracted the cotangent squared? So cosecant squared minus cotangent squared is really equivalent to a 1. And on the bottom, 1 minus cosine squared. Well, this Pythagorean identity has a cosine squared and a 1. So if I was to simply subtract the cosine squared over here, I'd be left with sine squared. And then that's not simple enough because we don't like to show them as reciprocal. So what is his reciprocal? 1 over sine squared would really be a cosecant squared theta. If you need to write out the Pythagorean identities in their different formats, that's fine for now. You'll get really good at this later, I promise. All right, 14, we're going to start trading everybody we can trade. So tangent is really sine over cosine. And then cosecant is really a 1 over sine. And then we're going to divide that all by secant, which is 1 over cosine. So So I'll start in the numerator. I see that the sines cancel, and we end up with 1 over cosine. And then in the denominator, we also have a 1 over cosine. Now you can change those both for secants, but anything divided by itself is just going to cancel out and give you a 1. And looks like we got a couple more. Tangent of theta minus cosine of theta. So tangent we're going to change to sine over cosine. And then cosine we're just going to keep as cosine. But because I'm working with a fraction now in a subtraction problem, I'm going to give him a denominator of 1. Now the only way we can combine fractions when we're subtracting is if they have common denominators. So my common denominator here would be a cosine. He's already got it. So what I'm going to do here is I'm going to multiply top and bottom by the cosine of theta to get common denominators. And I end up with, let's see, sine of theta, oop, not squared. Where are we at? Sine of theta. Plus, minus, sorry, cosine squared theta, all of it over cosine of theta. I'm just kind of looking here to see if there's anything more we can trade out. At first glance, the cosine squared made me think of maybe a Pythagorean identity, but since sine is not squared, I can't trade this for anything, so actually this is as simple as that problem is going to get. And then here, on 16, 1 minus cosine squared is this guy rearranged. So if I think about subtracting the cosine over, we'd have sine squared equals 1 minus cosine squared. So this is really a sine squared. So write sine squared theta, and then I'm going to trade secant for 1 over cosine of theta, and then I'm going to trade cotangent for, let's see, cosine over sine. And I'm going to simplify anything I can. So I see right away that the cosines are going to cancel. And then be careful. This sign is in the numerator, but it's sine squared, and then there's one sign in the denominator. So it's like when you have x squared over x. So only one of the signs are going to cancel out. So you still have a sine theta in the numerator, and we no longer have anything in the denominator besides a 1. So our answer there is sine theta. All right, I think that completes the first part of 1.5, and there is a book assignment on just simplifying trig expressions.